first Haskell meetup this year. Super cool that you all show up, and I'm happy to talk a bit about my experience with commercial Haskell programming. Hopefully giving the ones of you who want to start some commercial endeavor a bit of a head start, and the ones who don't yet want to start, the reasons for actually considering it. As I always wonder sort of who's new and how we grew, would it be possible for the newcomers to just raise their hand? Welcome. Very nice to have you here. And I hope also that actually this will be sort of the first talk in a series of talks where the ones of us who already have commercial Haskell programming experience try to spread the knowledge they've gained. So Jasper van der Jurk, at least, who was not here today, but agreed to me that he would also do 1 or 2 talks about that. Alright, so first a bit about me, such that you have some context. I mean, I started programming as a kid, and it was just fascinating to me, so I always followed this process. Well, what language can give me this ability to express myself more directly to computer better? So when I learned Haskell during my ETH, computer science studies, that was a real revelation. And essentially for me, following it in my spare time was clear, like, yeah, I want to do more with that. That just makes sense. So there weren't any jobs out there, at least not in Switzerland. So I did a PhD in formal methods and databases groups, and made sure that I had lots of tool development to do, which I could then do in Haskell. In that sense, it's commercial Haskell development. The 2 tools I've written, they're still in use. They're actually being maintained, and in one case actively developed. But I didn't have any idea of commercial development. I just wanted to get these tools written and get more experience. It's also not, some of the code I'm not really super proud of when I look at it nowadays. Then I had the great chance to join Better, enterprise e-learning startup, as a Haskell software engineer / architect, and really get the first-hand experience. How do you build web services in Haskell? How do you make sure they can always deploy them? How do you make sure they can monitor how they perform? And yeah, for me that was a very valuable experience. And sadly, the business model didn't work out, but I'm always proud to say that engineering could deliver. So I then joined IBM Research as a postdoctoral researcher, because there seemed to be an interesting project, and I misjudged that. So when the next Haskell opportunity came up at 11's Digital Finance, I was very happy to join them. And it's very interesting working there. So this talk is meant to be an interactive talk, so whenever you have questions, please just shoot. You probably don't have questions here about my CV, that's good. But one thing that was for me, if you look at how I went through it, is really that I started as a technology geek. I mean, that was just cool, using that technology to express myself. And now if I look back and I say, okay, I want to do commercial Haskell development, it's very clear to me, well, you just need to be honest with yourself. Technology is cool, but the first thing you want to know is, what is my business model? How do I pay my salary? And yeah, this is not to preach or anything. This is really from the lessons I've learned, to just highlight them. You do whatever you want to do with that. Second thing that helped me make better decisions, I think, is that I start really to understand that, look, what we're really selling is a user experience. And you can view every software product just from the perspective of the user experience. And then the software programming, it just becomes a tool. Moreover, it's as coming from the angle of a coder, and in my case also formal methods enthusiast, I focus very much on code. In the beginning, I think coding was there, and that was the thing I wanted to do, and I underestimated deployment. And now if you look at it from a commercial point of view, well, you get deployed once you deploy, so you rather make sure that it can deploy. It doesn't have to be a big thing. It can be a simple shell script, but you want to have the story figured out. Do that at the beginning and just reevaluate your deployment story as you go, as you reevaluate your architecture. And then you'll have a much better life as a commercial programmer. Last but not least, yeah, it's easy to become a bit blind when using Haskell. That like, wow, it's such a great tool. This guarantees it gives you, when it compiles, it works. This is all the case, and really for many software engineering tasks, I would claim it's an absolutely great tool. But make sure that your skills in using that tool are up to the task. There are some tasks that other can do that you're not ready to do. And then using Haskell won't magically enhance your abilities. And yeah, I wouldn't do systems programming using Haskell and FP, or if I were to do it, I would very consciously evaluate the drawbacks that I'm entering into. I mean, this is logical stuff. It's just, if you have something that is that cool as Haskell, for me at least, it's easy to get blinded. Alright, so that was all for the preachy stuff. What I want to talk about today is, if you start your commercial endeavor, you're going to write some files. And it really makes it a bit easier if you just have a layout on where does what go, which is already battle tested, which means that whenever a new file comes up, you know where to put it. So I'm going to show you the code layout that has worked very well at Better and that we're also using at Elevens now. Then there was a great change during my times at Better. We used Cabal mostly, and now there's the stack tool. I think for commercial programming it just solves almost all its problems. Yeah, so I want to give you a bit of head start and just point it out. And then I would like to talk about two patterns that we discovered made our life much easier. One is use a custom prelude, and the second one is use a principled approach of adapting package libraries to your needs. Furthermore, it is such that you're very likely to be writing in a team. And I must say, even if you write alone, so me and myself 3 years ago writing that tool, having style guidelines really helps. There again, the focus is really on guidelines that are sort of future-proof, that scale to large numbers of modules, large numbers of names, large numbers of interfaces. Yeah, that's about all. So let's start with the code layout. One thing I learned, first-hand experience, is that monorepositories, just a single repository containing all your code, it's just so much better than having a repository per project. Why is that? For me, the most striking point is that with a monorepository, you can have proper transactional changes across all your software artifacts. I mean, if you see that, you compare the two solutions and that, you're like, I would be dumb not to use a monorepository until I really scale out. And I doubt that's going to happen because Git is being pushed heavily by Twitter, and Mercurial is being pushed and made to work heavily by Facebook for monorepositories at their scale. I have two links that you can look up later. Then what I want to show you is actually an excerpt from the development repository that we use at Elevens. So this is also linked to from the talk and from the Haskell's page. Yeah, and that's what it is. Let me overwrite this. So let's just go through what is there and why is it there. I very much like the style of open source projects that have a README in every repository that explains, that provides the first point of entry. So here I've written up for you, for later readers, what's the intent of the different directories, and we can actually just go through that, and please ask questions if you have them. So what I found, and I introduced that sort of only at Elevens, is that it's really nice to split your source code into one directory of applications. So these are the leaves of your dependency tree. That's what in the end you deploy on your server. In most cases, these are rather small projects which just stitch together your libraries into a specific form to build a specific binary artifact. So in here I have a little word count example that I put there. What I've also found is that, for example, if you're in web development, you're very likely going to have both JavaScript and Haskell applications. So rather just make space in the apps folder by grouping it per language. And that gives you an easy means of communicating to other developers. Yeah, use the JavaScript application, this and that. So for the libs, the same factoring, there's Haskell libs. And there what also works very well is just prefix every library by your company name, or a short version. Because then you can properly talk about every library that doesn't have it in there, it must come from Hackage. Every library that has it in, well, it's yours. Where possible, just adopt the naming schemes used in sort of the standard Haskell libraries. Be it for names in the functions, so if you have some map style thingy, well, lookup is what you call how to look up an element there. There's all the options, you could call it get, but that's just not the name that has been chosen that most Haskell programs with experience would guess. And probably, yeah, that's anyways the ultimate test. A name is good if the first guess of your fellow programmer would be this name. That's what you want to achieve, because then even name something that he doesn't know about, if he thinks should have these properties, should be named that way, he looks it up and he finds it. That's just what you want to achieve. So that's why 11 space is our base library. It has the same function as the base library for Haskell. It just provides our basis, which is always available. So this library is released under BSD3, and it's the home for our custom prelude, and it's the home for our extended modules. We're going to go through that further.
I see
yes?
In your, I'm going to infer that because you have only a single src-tests, that you're mixing in the code and some data that you need to run your tests, right? Or you're sourcing them from completely different source. So personally, what I like to do is, I come from Maven way back when, so I like the source and then differentiating the code from the resources, but keeping them together so that I know that I'm dealing with tests, I'm dealing with the code for the tests, I'm dealing with data for the tests to see whatever large scale anything I have to do. So, basically, I like to keep something that tells me that, so basically I don't call it source test because it's test mainly versus its code, so it's production versus its test, and then within that it's either the code itself versus the resources, anything that is required.
So this obviously is taste. What I would expect is that if I grab the 11 space directory, I have a self-contained unit. So the test data should definitely be in there.
If you need data for your testing.
Yes, so I would expect data from a test to land here. Or test data, whatever. So I will put it in parallel. So the source test here, it really has just the main file for building the executable which you use to test this library.
And if you have some data that's for the application, you'd put it next to, so you would have source and data that are going together in production, for example, versus SRC test and test data. I don't find it very symmetric. I like if it
I
says
agree.
Test versus,
I agree. So
test
this
dash SRC versus test dash whatever. I don't know. It's just personal.
Yeah.
I like
So
things I was just curious how you.
No, it's more like we didn't have. So at 11s we didn't have test cases where we need a lot of data, and we didn't stumble upon that problem. But I agree if you can make things consistent, so
for
guessable.
Application, imagine you've got a lot of algos that you have to verify, so you've got a lot of data that needs to be known in advance so that you can verify that you get no regression when you're computing.
I totally agree. So this is not a one size fits all. It's
Just curious.
Yep. But here what we expect is we have a full source directory of sources. Carl, yes?
You can answer this question first if you are.
No. I was actually just continuing going through sort of.
So how do you think about splitting up the Haskell code into different packages? So here you have at least 2 packages. One makes sense because you're open source one of them. But would you have all of the Haskell code in one package, or how do you
No, what we use is that. My criterion is that you want, if you introduce a library, then you must be able to succinctly describe what that library is about. And if you have two libraries, their target must not overlap. Because otherwise, your fellow programmers are going to have a hard time guessing where does this functionality land. So that might well be that actually you have for quite a long time sort of like we have an 11's core library, which is sort of the catch-all for stuff that we just need, but there's no more than it's foundational stuff. Each of the models we can easily explain. But for example, if we talk about public key infrastructure or crypto, I would expect that there's an 11's crypto library, which packages that all up, and this is our interface to crypto then. Yeah. So I'm not going through the whole of L11 space because we're going to do that as part of looking at the patterns. I wanted to explain this principle, or the idea behind the Scratch directory is really that if you have a monorepository, then it's like, well, everything gets published immediately to all your coworkers. So it's actually really nice to give each employee a space where he can just do experiments, but which is tracked in the same history, so it's easy for him to use all the libraries that you've already developed, and once it's ready, you move it with the history, just in a single git move, to the right places. And similarly, it's really nice to share some of the dot files. So for us, for example, the Vim RC, most of us use the same one. Yes?
Yes. So do you suggest that for the Scratch library that you would just publish the changes directly to the master branch that you do in that space, and then people will say, okay, it's fair, he did a commit on the master branch without any pull requests or reviews or anything, but it was in the Scratch directory, so then it's okay.
Yeah, the Scratch directory is really a private namespace, just tracked in the same history as the rest.
Yeah, okay. Just interesting because it shows up in the history of everybody's, when they look at the master branch, so it's going to be polluted.
Well, but with a monorepository, you usually don't do a git log, you do a git log on a directory.
Okay.
And then you get exactly the history you're interested about.
Okay, yeah.
It sounds more like it's doing it like that. It sounds more like it's the dream that Apple had at some point to say just make the file system way more intelligent. So like it should be the file system that would be version controlled, but transparently in that sense, as opposed to saying that you're doing version control that way, where you start to put your private nodes with company assets, with to me. I started programming a long time ago, so I have this. I'm having a rough time reconciling mono repos with company assets versus my post-it notes. Let's make sure that
Yeah, so the Scratch space is not. I mean, if you want, you can use it for your post-it notes. It's not what that's actually not what it's intended for. The intention is that if I have some experimental code I just want to try out.
Yeah, no, I understood it that way. What I call post-it note is, I have an idea, I want to just see, what would it be, how does that work, but it's not something that, per se, I would consider company assets to say, because this is version control for all eternity. If you sell your company, you sell that as part of it.
Yeah, I can see that, but I mean, this distinction is still open for you to make. But this gives me an easy way to communicate my ideas and changes. And I think, well, one thing I have seen a distinction between how we work at Better, used to work at Better and work now at 11s versus IBM is that we make this assumption that all code is public by default to the whole company. Mm-hmm. And I think this just makes total sense, in particular for a startup. I mean, everything else is painful. And IBM is suffering a lot from not being able, at least IBM Research, what I've seen, they suffer heavily from not being able to share code between groups. I mean, they can do it, but it's not their culture. At least not what I've seen, to qualify as this is not on the internet. Okay, yeah, we have some other members here. Alright, dot files, obvious. Docs is just the one place under which you should organize all documentation. Yes, here in our case at 11s, we need to do some more cleanup and find a better naming strategy. That's a bit.
So you would separate the doc. So you would mimic the hierarchy of your libraries in the doc.
No, this is documentations. This is
more requirement level.
requirement level, architecture design. So yeah, there's cross-cutting concerns. A library itself, I would expect that is documented via the build.
So these would. So in there you would mimic your apps hierarchy, where you would say that per application, this is where you describe its genesis.
It might, for example, have one document explaining what apps do we have and how to use them, what's their goal, how do they relate to each other. So everything that is cross-cutting, that lands in here. If you have an application, I would expect that actually it just has a minus help, where it explains itself. Yes, so here we have the style guide that we use, which we're going to go look at afterwards, but let me switch back to, that's what I wanted to talk about. Right, so stack, I mean, I'm not going to make a full tutorial here on stack, but I think what is important to understand is that it gives you a solid story for multi-library and multi-application development, and it gives you good build reproducibility. You can read all on the internet of what are the trade-offs and so on. I must say, in my daily work at 11s, I haven't found any trade-off that would bother me. It just, for this, it just works. If it builds on my machine, it builds on the other machine. And what I've noticed is that it really helps if you just once go through the whole documentation and learn how everything fits together. Once you've done that, you can answer all the questions that you have about, oh, I would like to do this, and then you're like, oh yeah, that should go in that form. We have a setup at 11s where we also can use Nix to actually deploy, but that is a higher ramp up, and I must say I wouldn't recommend it immediately. I think Stack plus Docker, you might well be able to build a deployment experience that works for you. Yes?
Sorry, stupid question, but is Stack Haskell specific, or is it,
No, Stack is only, that's where Nix comes in. So Stack builds you the HS directories of apps and libs. If you actually have cross-language projects, then I think Nix actually gives you a very good answer to build reproducibility. So let's quickly look at what stack means. Stack means, in principle, for me, stack means you have a stack YAML at the root of your directory. Let me see. And this guy just describes what Haskell projects there are. Let's ignore, so here the flags, these would be flags for Cabal packages. We don't need any, I think this is just left over from the initial stack part. To me, the most important part is this packages section, so it's a YAML file. The most simple version is that you just point to the relative directory at which Stack can find a Cabal file describing how to build a library. So yeah, we want 11 space. We have this Acme word count utility from last year's talk, which is apps. And then one thing which is actually very useful is that if you need to do a few custom adaptations of external libraries, well, you can also just point Stack to a concrete Git repo and a concrete commit, and then let Stack build that. It will check it out, build it locally. Extra depth is also a useful feature to know about. It means that this is a library that you don't want to load when you do interactive development. So this is an extra dependency which is sort of outside the project you're working on. You can also do this, for example, 11 space, which would mean if I go into the REPL, 11 space is just compiled beforehand, and then that's it. Yeah, there's the concept of a resolver, which is the idea that this is pointing to a fixed set of versions of packages. These are exactly the ones that are available. These additional flags are really nice for company setup. Don't use the system GHC because that just messes up your config, particularly if you combine it with Nix, because the Nix GHC is a bit, well, doesn't find all C libraries as easily as it should. If you install the GHC, then I can really just change here, for example, to LTS4.0, and if there was a GHC upgrade, then that would be installed on all machines of all other developers on that branch. Yeah, and the build speed up. So that's about all. Usage is really just that. Do this. Well. So I should just be able to do a stack test here. And now I messed up the test because I renamed some of the examples. So that was the rename I did here. So that's the point at which my stuff is ready to be committed against master or against any integration branch. What we do very often is, I have it available, so stack REPL, stack GHCI, drops me into a shell where all of the modules are loaded. And what is really nice is if you use GHCID, and now I need to remember the -C. We probably want. That's not really unfortunate. So my current development mode is really such that I just load this in GHCID. It doesn't work. No, it doesn't work. So it should reload, auto-reload on a change. I haven't tested that, so I get the demo problem.
Maybe extra depth?
Did I go for extra depth?
Yeah.
No.
It's not saved.
Oh. Okay, I just want to demo that it would reload, but apparently it's not doing that. Let me see whether it tracks this guy. It's not tracking it. And perhaps it's also just an OS6 issue. Anyways, what you can take away from it is that it should be easy to set up GHCID such that it watches all your files and doesn't auto-reload. And thereby, you sort of almost get the nice squiggly lines that you have in Visual Studio and Co. Good. That's all that I want to say about Stack. Now to another pattern, which we look a bit more precisely at. What we found both at Better and 11s is that it's really nice to have your own prelude. What does it do for you? Well, it reduces your import clutter, and that was in particular true for earlier versions of Base where control applicative wasn't exported. Control monad was also very sparsely exported, but it's still true. I mean, it's just the standard prelude doesn't export enough for the use by expert programmers. And it also means that you actually get a nice installation layer. So the changes that affect the prelude, well, they only affect our custom company prelude, and afterwards everything looks the same because we can just adapt differences there. Plus, it provides you a principled way of introducing orphan instances. So just for me, sort of who knows the problem with coherency and orphan instances? Okay, then I better explain that. The guarantee you get when you use a type class is that whenever the compiler manages to find a type class instance for you, then for every type that it manages to do that, the type class instance that it finds is the same one. So this is independent of what location that is. Seems to be a bad explanation, judging from the puzzled faces. This is important because imagine you define 2 times an equality instance and they don't agree. Or ordering is even better. One orders ascending, one orders descending. Some parts of your code see the descending version, other parts see the ascending version. And now these 2 programs, for example, communicate. Well, it's just not going to work as you expect. So, in order to guarantee that this cannot happen, that you don't have conflicting definitions of type class instances, GHC by default advises you to define all class instances either where the class is defined, and that is really the earliest point where an instance can be defined, or where the data type is defined. And with these 2 principles, you get by construction the guarantee that whenever the compiler constructs a type class dictionary for a type, it's going to be the same one everywhere. Now, you can define type class instances at different places in different modules. GHC is going to warn you this is an orphan instance, so it has neither parent rightly available. And with orphan instances, you can actually manage to get into that problem that you have incoherent instances. So what we do is that, let me go to the better. Let me delete the test data. We have our custom prelude, and we're actually first going to look through that. So what does it do? What we do is that we don't export any partial functions, because it's actually a pretty bad idea to just call head. In most cases, anyways, the wrong functions with the default error behavior. And if you want the error behavior, you rather put a note in there why this should not be called. And I mean, the gold standard that you're always aiming for is you want to have pure total functions, so that don't throw an exception. Because they're really easy to use. I mean, if the types match, way fewer things can go wrong. Their types cannot lie, or can lie less. So there's the safe library, which exports a nice variety of these functions. Then there's a bunch of modules from data, which is just you can export all in the same module namespace. Yeah, then there's no real surprises. I'd say tagged, yeah, perhaps. The idea behind the tagged type is, I mean, data tagged tag A is equal tagged A, and it's a new type, here. It's a new type, defined this way. The idea is that it makes it really cheap to introduce variants of for example, ints or so of existing types, which should be distinguished. And what is particularly nice about that is that the convention for tagged is all the type class instances on the A are just carried over. Because otherwise, actually, you have for each new type, you have to derive all the type class instances. And now I just get to do type. Could we do type? A bad URL type is tagged URL tag byte string data. Yeah. So I introduce a data type that I just use without a constructor. This requires the language empty data decals extension. And I just use that as a new name for the tag, which means that URL and file path they are really different types. They can never be equated. And yeah, I found that this is actually cheaper than introducing all the new types and the machinery for wrapping it. Alright, that's why it's exported here. Generic, and then there's a piece of code which I've marked down here as experimental. It is this idea that many of our types need to be serializable. And actually many of our types rely on that they have a certain bunch of instances always available. Now if you want to change these instances that we want to have available, then you have to go to every declaration if you just do it naively. That's why we introduced this interaction via a template Haskell function that just derives the default instances. And we could just change it in here, well, in this code. We don't go in detail through it, to add further instances or remove some. If we see that, for example, we don't want to serialize via ASN anymore, we want to have our own toJSON class, it would be a one-line change. Alright. Yeah, that's about it for this. This again I think is best explored on one's own if one's really interested to see how that works. What I now would like to talk about is how we handle the orphan instances. Where are they? Orphans? Here. In order to guarantee that in our code we don't have any incoherent instances, we require that all orphan instances are introduced on a per library basis, so on always the library which defines the class, in modules named orphans.lib and then the library name. And because we always use our custom prelude, this guarantees that all these instances will be in scope, and if there was a conflict, GHC had a chance to warn it. It's not such that GHC doesn't warn us about conflict. It's just such that with orphan instances, some of the warnings would actually occur at link time, and at link time it's not GHC, but actually the standard system linker, and the system linker doesn't know anything about type classes. Backpack might change that in the future. So yeah, and then there's no surprise. So here we have the orphans, for example for ASON. There's a bunch of things that are missing. Yeah, like we can't serialize byte strings, and that's okay. It's okay for ASN not to export a toJSON instance for byte strings, because it's not clear how to convert them to JSON. But for us, it's fine in our prelude to make this decision. Yes, we're always going to serialize them using base 64 encoding. So that's also the reason why I'm not publishing this library as a library on package, because it has opinionated choices in there. And there might be some parts which you could just publish and always just take over. But other parts, yeah, that's companies' decisions being reflected in the code. Yeah, there's no real surprise. It's more that when you see that you build on top of package, there's a bunch of libraries that sort of complement each other in functionality. And our prelude, or our base library, serves as the glue between them and provides joint versions where all the instances are declared, and sometimes also modules are exported as one.
But it means you make that decision of these serialization types, for example, you make it at the library level versus at the application level?
So this we make currently because that is okay for the goals we're pursuing.
Mm-hmm.
We make that on a company level, we say.
But it means that it's potentially, it means it wouldn't scale to multiple projects where you might end up still wanting a lot of the shared machinery, but a different way to apply some of the details to it.
Well, serialization actually is an interesting topic. There, my take on it is actually that you want to control the serialization probably on a per project level. It's
Yes.
actually ASON. I think it's great the support it provides to build JSON values. The type class machinery, it's great for one-off things, but for you as a company, you want to have your own bunch of type classes that build this translation layer.
Mm-hmm.
So that for me is then also the reason why I can say, okay, ASN, I'm free to expand and just make one decision. Everybody knows what decision that is. If you in a project have specific needs, you implement your serialization, your automatic serialization deriving code yourself there because you design it and you tailor it to the needs. Be it either as a separate library, where you say, well, all of these components use this protocol to communicate, and this is the library, the protocol library that provides us with the easy way to build the messages, or you do it on a per project basis. And obviously, I mean, if your company becomes large enough, then it feels like a company with company and companies. So then this hierarchy might not scale anymore, or you have to rethink it and adapt it.
But it means you would end up at some point having a matching or an equivalent preludes series on the apps side, where you might define types for the apps that are not the ones necessarily that they.
I wouldn't think so. I would expect, so the apps actually, I really see them as single module applications that stitch together what libraries expose. And I totally agree with you that you want to design libraries that are context agnostic. And so if you come to the point that you see, okay, what we're doing here is killing our context agnosticity, so it's introducing singletons, then you remove that singleton, move it to the right place to gain the context independence again. So that, the rest should be surprising. It's surprising. Good. Now, having said that, there's a second kind of impedance mismatching which you typically must do. Namely, it's that there's good libraries on Hackage, but you might only need parts of them, or you need two libraries playing together, like the lens library and text values. And the lens has some functions, some lenses that are really nice to be available for text values. So if you just use Hackage directly, you end up with way more imports than necessary. And you essentially end up with redundancy in imports if you look across modules, because you always import these two or not. So that's why we came up with this dot extended pattern, which is just one means of deciding where to place such code that just adapts Hackage libraries to your needs. I think this is best explained on an example. There's a link in there where Jasper van der Jeugt, colleague from the better times, that's fun, but it wasn't meant like that, explains them. Alright, so for example, data text extended. What does it do? So the rule is that data text extended should export everything that is in data text. So a dot extended on some module name should export the module name itself. If you wouldn't do that, then it would be really cumbersome to guess, oh, this function, is it now from the extended version or not? And this also gives us a principled means for, if you have an extended functionality that we implement that actually is a good candidate for integration into upstream, well, once it gets integrated, we just have to change the dot extended to not define it anymore, but all our internal code remains the same. So for data dot extended, we want to have a show function. It's not performant, but it's just something you need often, and for performance uncritical code, that's okay. And we want to have these two lenses available, because sometimes they're just really nice, converting between strings and text and the other way around. And of this kind, you actually find quite a few versions. So what do we have otherwise? Control monet except, which is essentially either monet transformer. We have a bunch of variants on how you can transform errors, which we found to be really useful. And the one thing we want to avoid with this the extended pattern is having a generic utils module, which is just the home for all your utilities that you write, but actually it becomes really hard on one hand to guess whether something is in there or not, or whether it's in the utils or in the original module. Plus, this utils module is introducing a dependency nightmare. And yeah, so I think
in a sense you want n of them, one per library, as opposed to having a grab bag of everything where then it becomes difficult to track where it came from.
I would even go further than one per library. I would say one per library module.
Yeah.
It is the case that some libraries, so for
track the changes as close as possible to the source.
Yeah, like you know the library, but now you just get a bit better version of it.
Yeah.
PostgreSQL simple. So, yeah, it's a great library. We make good use of it at Better, but it has a really import verbose interface. So every type is exported from exactly one module, but often you need, for example, 2 field and 2 row. These are just type classes for converting 2 fields and rows. You obviously need them both. So for PostgreSQL Simple, we always had these 5 or 6 line imports. That's where we decided, okay, there's a PostgreSQL Simple extended, or even just in that case, better.PostgreSQL Simple, and that's then the module you use. So this is not a kind of adaptation that you should just be aware of, that, okay, if the library is cumbersome to use, build your own module, re-export the stuff in the form that you can use it, and off you go.
You're even making your code bulletproof against their changing their module.
Yeah, I must
You don't
say,
have to track the same for anything, any types that if 2 of them get merged in a single module in the future, you have a single place to change instead of having to track everything all over the place.
that is true, although I must say that wasn't our main problem, that they were changing too quickly. And in particular, I wouldn't advise actually against eagerly insulating against these changes. So I would advise to do it lazy on demand, know the techniques you have available.
So what is your chief criteria, your main criteria for saying it's being repackaged like that? If it's not to say isolate your code, or like, what's your first criteria to say yes or no to doing it?
So for .extended, the criteria is I need an additional utility which could land as well into the mainline, into the upstream module. So then this utility goes into .extended version, and from then on you use the .extended version, like the show function for text.
Okay.
For repackaging another library, it's the point where you see, okay, I have the same list of imports in multiple modules and I want to share that. That's the point where I think about, well, shouldn't we perhaps have a company-specific database access layer? And that I would go for a single module design there. You import one module qualified under a short name, and this gives you a batteries included version of the libraries that play together.
But you would probably name it something company specific.
Yes, that's the other thing, is 11 space is the only library exporting anything, exporting modules without an 11's prefix. So what I want to achieve...
Implied.
Pardon?
It's implied in a sense. Or
No, it's not implied that we couldn't have other libraries that would export into the non-prefix namespace. So the criterion, what I want to achieve is that my libraries can coexist nicely with any library being published on Hackage, or actually any library being acquired from another company. I mean, this is Java does this the same way. They even have a long way, but a good way to make it unique, I think, by the full company's DNS name. So, yeah, I mean, I'm not saying there's anything surprising or rocket science. It's really just putting it all together and making consistent decisions. That's the main effort, actually. All right, I was here at this talk. Oh yeah, now we have a few more things to discuss or look through for your questions. So, style guidelines are always a good source for debate. But on the other hand, not having them, I think, would be stupid. Having some and following them as good as you can, I think is a way better case. So, the guidelines we use are based on Johan Tibel's Haskell style guidelines. Adapted in some cases to make a few, to allow for less options, where it doesn't hurt, and adapted with a few other sections about things, how we deal with Haskell code. You'll see. But one thing I found to be really a strong criterion in distinguishing between different styles is to do change-aware coding. To write your code such that if a change happens in another place of your code base, if that change affects the piece of code you wrote, the compiler is going to tell you about. So that actually immediately rules out default cases for for company-specific data types, because there might always be another constructor added, and that would just go in a default case. So rather just enumerate it out. It also means that you want to limit a bit on how much type class inference goes on. So in strategic places, placing more restrictive type signatures can be a good thing. Also because of this first principle that readability, if you needed the type annotation when writing it to get it to compile, better leave it in, because probably it's very helpful in understanding what the code is doing. And the other thing is that some layouts, some code style guidelines look very nice as long as stuff is small. But when stuff becomes, when we have large numbers of functions and large numbers of modules, it becomes really, okay, I like it when there's a clear rule on how to just organize import, where all of them read the same way, even if they read a bit less nice than otherwise. But yeah.
Can you give an example of that?
Well, one example is naming. I rather go for a bit longer name. So names are obviously. A good principle for choosing names is that they're chosen according to the scope, the scope in which they're accessible. So the larger the scope, the longer, the more explicit the name. And what I try to do is, when I choose a name, to think about, well, could it be that this name is occupying more of the namespace than it actually should? Would there be another alternative which I would need to distinguish, which I cannot distinguish because I'm not having this additional prefix or designation in there?
So you mean, like, if a function can be used for a lot of things, its name should be short, and if it can only be used with a specific small set of things, then it could be a longer name, like this?
That is actually another criterion. But it's also like, it's totally okay if you just write a function and calling the parameters with short names. If the function's body is half a page, well, that's fine. There you have, there's going to be a local, essentially as a reader is, okay, what's the local convention on names? Oh, it's these, and you see where they're used. It's also what I found actually that it works pretty well is that if the top level declarations are fully explicit names, you always can distinguish between, if you read a text, oh, explicit name, that's top level, short name, that is more local.
Did you have a point about the imports as well? Did you say the imports?
Yeah, the imports, I'm using this simple scheme of just order them alphabetically.
Yeah.
Don't do any semantic ordering, which, for example, Johann's style guide suggests that you should differ between internal modules and external modules.
Mm-hmm.
The ones from Haskell, the ones from your company, the ones from your library. Because actually, this is very unstable under change. It might well be that your library gets open source, goes into Haskell. Oh, should you suddenly shift? But if you use a good naming scheme for your module names, then actually alphabetic sorting is going to be a really powerful criterion. So what else do we have? Let me see, time we have? Yeah, I don't plan to go through the whole style guideline. I just rather like to point out some things that I found really nice or helpful. Right, actually here we already have the first example. The style we're currently using is sort of a style where by default you indent 4 spaces, but you have a half indent available for places where it helps readability or where it saves indentation. So like unindenting the var bit is a really nice way to distinguish between your local definitions and your body. There's also a very interesting criterion or powerful criterion is make sure that your indentation is not dependent on the length of names, because otherwise it's going to be all over the way and you're actually going to be you're going to prefer shorter names just because it saves you an indentation space. And like for case distinctions, that's a case where I found it really pays off that just do a half indent, because then you have the actual body of the cases on the 4 indents again, and it's visually easy enough to separate because an individual case is going to be a single line, and if in doubt, just use vertical empty lines to separate things more clearly. Whether you align like this or this depends on how OCD you are. I am. I haven't done it here.
What about a new line after the arrow?
New line after the arrow? Here?
No, after the other arrow. Arrow. New line.
You want to do this?
Yeah.
Yeah, this is another option. I think this is, we get in the space of everybody chooses what is best for him. I think we all agree this would be confusing. I think these two options that we just had are equally good. It's really, I mean, here we get to the point where how often is this code going to be read? Is it just your little test harness that if it were borked it would anyways show? Or is it the core of your distributed agreement protocol where you just want to make it as readable as possible? I personally also like just have inline comments, rather have a few more. I mean, there's this argument that functional code is so to the point that it should just explain itself, but I found that it really helps to give a hint of, yeah, this is going to do that, and then you already have the right picture, and then it becomes easy to interpret it. Otherwise, yeah, it's hard for newcomers or for old code. Plus, you can then also use this style of coding where you just say, okay, do this, do that. Well, better explanations, but you can really tackle big functions just by listing what you expect to do and play a bit and then start to fill out. All right. Yeah, here's the example of when to avoid indents based on naming. It looks really awkward, in particular if the identifier is 4 characters long, but well, in this case it fits, so I would indent it like that. I would write it like that. But if let's do a few more. What do you do? Is this long enough? Still not. Okay, if that were the function, well, actually, probably in this case, if it's that uniform, I would go for this setup. Yeah, but otherwise, just wrap up the arrows. And vertical space is way cheaper than horizontal space. It's not completely free, so sometimes you have to make trade-offs. All right. But yeah,
so,
this.
Your advice of, in a sense, you're saying write it for the reader. Don't write it for yourself. Write it for the one reading it.
Yeah.
So when you write it, don't. Yeah. Read what you write.
Yeah, it
Don't
also
just
means that.
intend to write something. Read it as you write it.
Yeah.
Be the first consumer.
And one could put that even a bit further and say, actually, if you really want to force that, then it's good if you don't immediately get squiggly lines. Because if you read the code and play the compiler yourself, you're going to structure the code more readable than if you just type, oh yeah, type doesn't match, I need to do that, need to do this, and suddenly it works, it types, and it's good. I mean, I know of at least one example of a fellow programmer where when we worked together, and he saw my mode of just writing a day and just without asking the compiler, that he first questioned it heavily, and then afterwards actually tried it himself and found like, well, actually, he became way more productive and could split it more into semantic parts instead of just code that somehow fit together according to the types. Yeah, this one is actually, I think, one of the few syntax decisions in Haskell that they did a bit suboptimally. One thing you can, I mean, it's not a criticism of Haskell, it's just if you require in a language white space around your operators, you actually gain a lot of syntactic namespace. So for example, Haskell really has the problem that you cannot use the dot for record field access. Because it just cannot distinguish it from the dot as function composition. But if you had spaces, then actually identifier operator would mean something different than identifier space operator. And I think actually this is still very well parsable for humans. And I think PureScript, for example, has done that and enforces white space around operators. So we can still help our fellow readers and put white space around operators. Edward Kmet would disagree. He really likes his lenses composed with consecutive dots. But yeah, it's a matter of taste. Yeah, here's another example of one thing I just stopped doing. Early in my earlier code, if an algebraic data type would fit in a single line, I would just write it that way. But I found that this actually doesn't help reading, and it's really, in most cases, anyways breaks because you're going to add a constructor more, you want to add comments. So if you just start with a for indent and equals on the first line and just list them top down, that always works. Talking about records, probably, well, actually I just wonder. Let me see. So if I were to write this, company, companies just have names. More syntax. I think now it should be okay. So, who knows the reason why one should avoid this? Yeah. I'm not going to ask. But good that there's actually few who are confident to know the reason. The main problem is this introduces, for example, name. I mean, okay, this is entity. Pardon? So this introduces name and it has this definition. So, although the syntax looks innocuous, it just introduces a bunch of partial functions that are going to bite your ass. So, yeah, this actually I consider a misdesign. So just
compile to Word.
I don't think so, no. It's like head and tail. Yeah, I mean they make sense in that context when Haskell was growing, but nowadays it's not a good idea.
But having a warning for it would make sense.
Yeah, true. But once you've learned it, it's easy to avoid. Good. I mean, it's also a matter of taste. I found that prefixed constructions work better than suffixed ones. It's sort of, to me, it goes in the same principle as the don't make your indentation depend on the name on the length of names or length of expressions. Well, here, all of the same kind of operators are going to be on the same level. So if I want to do monoid append of them, I will probably also go for something like this. Okay. Yeah, the other thing I noticed is that it really helps you if you learn upfront about how to use Haddock, the Haskell documentation tool, just the simple comments, and then always consistently use that. And similarly, consistently use the Haddock export, Haddock way of structuring exports, and just make a nice list there. Although, I'm saying this even though I'm actually very seldomly looking at the Haddocks, but I'm very often actually looking at these export lists. So I mostly program against the source code. But yeah, structuring that nicely instead of something like this is really well worth it. What can help is that when you're developing, you just go for an export all, and once you're finished and have put stuff into modules, you close the export lists. Sorry for just jumping around. So here we are. What else is there that is really interesting? Right, so this is, here we come to one of the very controversial parts. How to do imports. We currently use the rule that you either go for a full name for the abbreviation or you just go for one of the capitals. You're rather free. We try to, for modules that we develop internally, to give a suggestion on how you should import that, such that in different modules the short abbreviations sort of match up. And I mean, the more often a module is used, the shorter the abbreviation it gets. But it might be that really different parts of the code base have different abbreviation schemes. It's very hard to be consistent there because there's just way more names you need to deal with than there are characters. I tend to wrap my imports if they're named in this form. I tend to always leave space for the qualified. What's the reasoning there? I found one of my sort of implicit duties was reorganizing dependencies. And there I found it really helps if you can read the import lists well, because then you get a better picture of what actually is depending there. Well, why do I have that import here? That doesn't make sense. That's not the same kind of problem that this module is solving. And often it was just because that module defined a utility that was useful and it wasn't moved because it didn't have a proper place. And suddenly we ended up with long dependency chains and sometimes cycles.
Are you using Jasper's formatting tool?
Actually not, because it doesn't. It goes for this very lengthy import. I will probably do it about here. But yeah, should actually talk to him or should see whether we can do a pull request that does this formatting, which keeps the 80 characters. Yeah, this is probably better read on its own. One thing I also learned that better is whenever you write English, write proper English. I just like it. It's a really simple rule. Once you get accustomed to it, stuff just starts to read better. Yes. Right, so here's another section that I think has to be, it's important to know about. And I mean, Haskell's a lazy language. Laziness is really cool because it allows you to abstract over control flow properly. But for all the data you keep in memory, it makes it super hard to reason at how much data does it reference. But I think also the experience that better shows is that if you make all your constructors, all your data types that you define explicitly strict, then you get this reasoning principle where you can say, well, do I force one value or do I force the head of this value, like something that you put in a cache? Is it fully strict? All right, I can just compute its size. I know how much it's going to hold on to. And I don't know, correct me if I'm wrong, we didn't really have space leak problems. Did we?
You would remember them.
We did maybe occasionally have one if someone forgot to add a bang, yeah.
Okay, then so just follow the bang rule. It doesn't look that nice, and in particular, this feels like an premature optimization. But here I'd actually say not putting them is the premature optimization. And I could debate of whether it would have been better if the Haskell language would by default have strictness for data types and laziness for function arguments. But that's just how it is. If you know it, you just do it.
Well, actually, one thing is sometimes you need laziness in a data type, but it's very rare. So then you make it explicitly with a comment. The other thing, though, is just because you make a data type strict, you may sometimes have to put a $bang in your source code in various places. Those are the ones that are a bit harder to follow.
Yes, that is true. But that's a topic for another lesson. Yes?
Will you just disable strict data extension when it comes, when it becomes available by default in all your projects?
I must say I'm not that convinced, because so the strict data extension is, yes, it does exactly what I was saying, but it's not compatible with me moving code from my library to a library on Hackage. So then I always have to think, oh, does it have strict data? If not, oh, I have to edit it. To me then, if I think about that, it doesn't buy me enough. I mean, it's a bit ugly, these exclamation marks, but it's not that ugly that I want to have this the source of accidental mistakes, where, yeah, I could just have a principled approach where I think about strictness and laziness of my data type arguments, and then I'm done.
Well, for polymorphic types, it's a little bit more ugly, right? The bank, because then you need parentheses,
You mean, for example,
maybe
map?
double or something. Yeah.
Yeah, and we must be honest with ourselves, so maybe double, the
Yeah.
bang is not enough. You should import the strict maybe from the strict base types library. But I must admit, I'm not doing that consistently yet, but I'm going to do that consistently once we hit production. So I can't yet give you a good scheme of how to deal with the mismatch between having strict maybe, but wanting you to put it in a map, and yeah, there's going to be a bit of work there to do impedance mismatching. Yes?
Wouldn't you export the strict maybe from your personal prelude?
No. Maybe is an abstraction for a partial function, for a computation that is partial, and it must be lazy,
Oh, really? Okay.
because otherwise this doesn't work. Unless cont. Okay, now I need to make sure that that's the right thing that doesn't work. For example, that wouldn't work. But now you might argue we shouldn't have partial functions anyways, but that's then an argument. And that actually, I think actually would be way more surprising, because you're used to it. So I'd rather have, I'm opting towards having a something perhaps in this direction. 11.
Sorry, I don't understand this, because unless will be lazy on its second argument. So what's the problem here?
I'm not sure it is it?
Yes, it is.
Okay, then what about this?
Depends on the instance. Okay, yeah. And of course that's hidden behind some other calculation.
Yeah, so, okay, we have to look a bit more closely. I'm pretty sure we can find problems. Perhaps for the maybe it even might work out.
Well, it wouldn't be a monad anymore, for example. So, and sometimes you do use it kind of as a monad thing. And
yes,
then,
that's
and it's
what
really
it's
important that
about.
it's lazy. Yeah.
It's also the strict maybe actually doesn't have a monad instance, because it's not a monad under bottoms. But good catch. What was it about? Right. So I think this could work that you have a 11 preludes strict, and essentially you typically import qualified.
Just type it again.
Just, yeah, consistently the S prefix is all the strict variants, and it provides you with the easy functions for mapping between the different cases. Alright, so this, for example, putting unpacks in, that is now premature optimization. That's where the GC extension on unpacked small strict, or
Oh, right.
yeah, this one is too strong,
Okay.
because this one means that if you have a field which is a big record, then the whole record would be unpacked. But there, the one indirection actually is in many cases going to save you memory and going to save you in copying. So you only want to unpack the word-sized, or perhaps 2 or 3 word-sized data types. And you actually need to look careful at how many times do you call a function which requires access to the data in the unpacked field. Because on every call there, GHC is going to allocate a new structure and going to copy them back in, because the other function is going to expect a structure where only these are in there and not the large one they unpacked. Yeah, for these extensions, that's perhaps another thing that really helps. At least somebody in your company should know the whole documentation of GHC with respect to language extensions. They have very good examples why they invented that language extension. Many of them, they really make your life easier. You should be conscious about which ones you use in your company, but you shouldn't, I think one shouldn't be too conservative with using them. If you use Haskell, then you anyways use GHC for production, and many of them, they just extend the language in very clear and clean ways. Yeah, point-free style can become pointless style, but many know that. You definitely want to have -WAll. Not sure about -WError, about enabling it. We currently enforce it by convention. It's just bad style to commit and master, which is not wall clean. But during development, WError is really inconvenient. Now, one thing to note is, I learned that only recently, that there's one kind of patterns, so one kind of partialities, which is not captured by -WAll. It is cases where you write, so let just x equals head name. This will compile with thrown error.
Warning.
So it only gives a warning with this. It's so patterns on the left hand side. Yeah, warning free compilation. Sorry.
So let patterns are.
Yeah, in let and wheres. So if you have on the left hand side of an equal and also top level declarations. On the left hand side of an equality sign, there's a partial pattern. It's not going to warn about.
Those are irrefutable patterns. A bit weird, right?
No, it's not about the irrefutability right now.
Okay.
It's just about incompleteness. That you unify just something with something.
Okay.
Is it more about patterns in do notation? I guess not. I mean, you can also have in do notation patterns.
But there, it's okay that it doesn't warn, because well, until we have the monad fail proposal in, because it dispatches to fail.
Yeah,
and you
always what you want. That's
well, but it's a design decision you can make, and it's consistent. Whereas the other one is like, you don't introduce with the do monad pattern match. You don't introduce partiality if the monad doesn't want to. So if you can handle fail, it's going to be handled. Let's look up the unit patterns. Lambda expressions and pattern bindings that only allow a single pattern. So if you only have a single option, then that's where it breaks. Yeah, so these two examples probably sum it up. All right. What do I want? I want start out. All right. One thing that I think also works pretty well, we use it both companies, is that having a clear semantics, what does a fix mean, what does it do, and the note mean, and sort of non-standardly tagging them not with the addressee, but the author. Why tag it with the author? I mean, yeah, in the first round of check-in, you have git blame, but code tends to move around all places. This way, the author annotation is persistent over code changes, whereas git blame, would not be. So if you really want to address somebody, then you do it in the comment or the gif. Fixme should never make it into master. To-dos and notes are okay, and notes are sort of even encouraged. yeah, that's all for the style guideline.
Is public?
Yeah, so this is linked from the Haskellers Git repo, from the talk, and then you have the slides and the code. And as said, it's BSD licensed, so feel free to just copy into that for your needs.
But rename it to something else, right?
Yeah, the BSD Free license says you must not use the names of 11s or any of its authors to endorse.
Well, endorse,
your
but
derivatives.
also you might want to rename the module.
You probably don't want to use 11 space, but in principle you could just work straight against it if you don't publish it. Yeah, that's about all. I mean, there's lots of resources. I think Stephen Deal's What I Wish I Knew When Learning Haskell is a really good index on what you should know about, at least sort of have the mental index for it.